Kia ora team. Today we're going to go through how to use a multimeter to test for resistance. If you need some assistance with how to use the multimeter, what the functions are and how does it work, go back and have a look at some of the previous videos. Today we're going to go straight into how we are going to physically test for resistance. Let's have a look. So, you'll see on my bench here, I've got a few little gizmos, primarily, most importantly, my multimeter. And you'll see here that my dial will cycle through a number of functions. The ones that we're going to use today, we're going to use two. We've got this one here with the diode and buzzer symbol, and we go around here to my ohms scale, or ohms function, that's denoted by the ohms symbol there. We have two scales, 200 and 200,000. It just depends on what the size of what I'm measuring. So it just gives us different scales for different resistances. We're going to start with the 200k ohm scale today. So the first thing I'm going to test is a resistor. I have a little resistor here, and we would be able to see there that the color code is brown, black, yellow, gold. That will tell us, we're not going to worry about that too much today, but that will tell us what the ideal value or the supposed value of this resistor should be. And if we were to suspect that this resistor was faulty, I would be able to test it with my ohm meter here to prove or disprove, as the case may be, the actual value of that resistor. So let's try that now. All I need to do is make a circuit. I'm going to take my two multimeter leads. I've got my multimeter set to the 200,000 ohm scale, and I clip this end on here and this end on here. You'll notice that I do have clips on my multimeter. That is to make my life a little bit easier. Your multimeter may not have those. It might just have the probes like this one here. But for the purposes of today, I'm going to make it as easy as I can. And we will see on the screen of the meter, if I could get it out of the light, that it says 98.6. 98.6. Notice again that we are on the 200k ohm scale, so 200,000, which means that this value here is in thousands of ohms. So we've got 98.6 thousand ohms, or 98,600 ohms. And all I'm doing, as I said, is just measuring end to end. I place the end, one of my meter probes on each end of the resistor, and that gives me the reading. If you watch the screen as I disconnect it, you will see it now goes back to 0 OL, which means overload. It's not measuring a circuit. So very simply, I can measure a resistance just like that. I can use this for many different things. I could be measuring the resistance of an element inside a jug or a heater or something like that. Resistance testing is used in multiple different places, but the function will always be the same. I put either end of my probes onto the terminals of what I want to test to see what the resistance is between them. Now, when we talk about testing resistance, the reading that we're going to get in ohms, there is another slightly different test that we do, or that we talk about when we're talking about resistance testing, and that's continuity. So if we look at our meter again, we will see the buzzer symbol at the top here, and I'm going to change to that function. What the buzzer symbol does, it is still a resistance test, but in this case, it's not going to give us a detailed or very accurate reading. What it's going to do is buzz when it sees a circuit. So if I just touch my meter leads together, now we can hear the buzz there. What that's doing is the meter is sensing a circuit through the leads, and between the probes, it's a very low resistance. Obviously, there's no resistor in there. It's just the resistance of the leads. So the meter is telling me, yes, there is a circuit there, and it beeps. This is really helpful for fault finding. If I want to know, does a particular conductor go from one end to the other, as in, is it broken anywhere along its length? Or if I'm fault finding, trying to find out, for example, are the right things connected to the right place? If I think this red wire should be connected from here to here, I can put my continuity tester across it and go, yes, that is in fact where it is connected, or no, it is not connected. It can help me find where a wire is connected. If I'm in a messy control box, I can put one of my probes on one end of a wire, and then I can test to other wires inside the control box and see which one of those is the other end of my wire that I'm looking for. So let's do a quick look at a continuity test. So an example of a continuity test, I'm just going to change the meter lead here to the probe to make things easier. And you'll see that I've got in front of me just an ordinary standard multi-box. It has a plug on it that I plug into the wall, and then it has the outlets here. So one of the things I might do in this example, we probably wouldn't normally do this, but in this example, I'm going to see if I can figure out which part of the socket is connected to each pin on the plug, and I'll use my continuity testers to do it. So I'm just going to clip onto the plug here, onto the left-hand terminal as we look at it. And if I plug my probe into each of these outlets on the socket, when it beeps, that's the one, I know that that's the one that it's connected to. So I go to the bottom one, nothing there, we see nothing on the screen. I go to the right-hand one here, and in fact, I get a beep. And we'll see it does have a reading 0.001. It beeps rather loudly, so I'll unplug that. And it's telling me that the right-hand socket is connected to the left-hand pin, which if you imagine me plugging that in there, that should be right. The left-hand pin connects to the right-hand socket. I can then check to this one here, and if I, again, no circuit, so it's not connected to that one. And then if I run down each one here, you should find that same pin is connected to the right-hand socket on every single one. Again, I can change this onto the bottom terminal and test for continuity. Obviously, the bottom on the plug should go to the bottom one on the socket, and in fact, find that it does. This is not a usual example. I would expect if I bought a multi-box off the shelf that the right things are connected to the right places, but you can see how this would be a useful test in order to be able to figure out what is connected to where. Are the right things connected to the right places, or how do I find out where this particular wire is connected to? That's all for today. Thank you for tuning in. Have a look at the channel to see other videos in this series around how we do testing and uses of our meter.